to use deep learning. Well, this short presentation will give you a brief overview of when deep learning is used and provide discussion around when you actually need to build deep learning models from scratch. So deep learning takes its name from deep neural networks. Artificial neural networks were inspired by progress in brain research and were discussed since 1950s. So here is the picture of biological neuron, and this is analogous picture of artificial neuron. So you have some input connections with different weights. They summed and they multiplied by some functions called activation function to provide the output. This is a single layer perceptron. So basically this is this logic here. From about 1960s. Frank Rosenblatt, a person who created it, this particular machine, only 20 by 20 photocells, single layer. So 20 by 20 means 400 pixels image. And to change the weights on the connections, they used electrical motors to actually change the resistance of the mechanical resistors. So this is a single layer perceptron, and this is a deep network, deep neural network. So it has some inputs, it has outputs, and in the middle it has hidden layers. And this is the basic structure of like a forward neural network. There was a lot of progress over the last, let's say, 30 years. Jan Lacon was a big breakthrough. Well, currently he is a main AI person at Facebook, and he's also professor at NYU, University in New York. Very talented person. He worked with, I think he worked with Hinton at some point, but this was in New Jersey at AT&T Labs, and he created convolutional neural networks which were used to recognize handwritten digits, and they were actually used in banks after that. So this was a great success. Back then, computers were very slow, and he used some specialized computer equipment. Since then, a lot of progress was done in University of Toronto, Canada, in the laboratory of Dr. Geoffrey Hinton. And in 2006, there was a seminal work where the deep neural network, like fully connected between layers, was trained. So it's called the deep belief network. And then several years later, Alex Krichevsky, working in his lab, created a new version of LINET. LINET is this network by Jan Lacon. That's why it's called LINET, Lacon. And well, Alex called it AlexNet. And the big difference is that he used the GPUs, video cards. And this made the whole thing 1,000 times faster and became the major breakthrough in the main approach. And after that, everybody started using GPUs and specialized CPUs, well, like TPUs, like Google, for example, tensor processing units, and so on. And the progress was developing very fast after that. So we had tremendous growth and acceptance, and people started doing AI, which became possible. Well, when people say AI, this is the same deep learning, machine learning, but dealing with activities which usually are associated with human level intelligence, human abilities, like ability to read, understand speech, understand images and video, drive cars, and so on. Extract information from texts. There are multiple architectures how neural networks can be built, and they become bigger and bigger over the years. Like in 2020, the biggest network was GPT-3. It's a language model from OpenAI, and it has 175 billion parameters. If you just think about it, if each parameter is a float number with 4 bytes, so you're talking close to like a terabyte of data just to keep the parameters. Never mind how many thousands of computers and millions of dollars you would need to train the network and to deploy it and use it. So there are multiple network architectures which were designed over the years. So here is a short list, but there are many, many more. All major clouds, I'm talking about Google, Azure, Microsoft Cloud, of course, Amazon Web Services, AWS, they all provide models. And more than that, they all provide architectures which are pre-trained. So you don't have to train your network on millions of images. You can just use a model which is already pre-trained and maybe just tune it on maybe a couple hundred images which you have for your specific task. So this makes models very accessible and affordable, practical. It's very fast to start using the model. Also, many models are provided as part of so-called cognitive services, where they're already trained, and you're getting API access, so you can just, for example, send an audio file and receive back the transcription into text. So you don't even have to train anything. You just use the models which are already trained and ready to go. So very rarely you actually need to do heavy lifting and train models from scratch. Most common data science tasks, when people talk about machine learning, they actually dealing with tabular data. So think about Excel spreadsheet, think about relational databases. So you have rows and columns, and there is a lot of data science that can be done with this kind of data. You're talking about predictive analytics. So people love to make predictions in business. Risk assessment, forecasting, maybe some seasonal changes, trends, investments, of course, optimization of business processes, cutting costs, recommender systems, like people who bought this also bought that, and so on. All this is dealing with tabular data, and there was a lot of progress done in mathematics of how to actually solve these problems. And they usually solved by classical machine learning methods like linear regression, logistic regression, and ensemble decision trees, such as random forests and boosted trees like XGBoost, for example. There are many tasks which can be done using cognitive services, which I already mentioned. These are ready-to-use services. The problem with them, though, that they may be costly. And you can try them first. You can see if it is possible to do what you want to do. If, for example, the quality of your data is good enough to do something with it. But if the final result is not good for production because it's too expensive, what you can do, you can use open source tools on Linux servers. You can prototype them on the cloud, or you can go for your own data center and your own private cloud. And when you're dealing with deep learning, it's very important to have GPU-enabled servers, which speed up calculation 1,000 times, or at least 100 times. And go-to approach is to use open source machine learning software like Kubeflow, developed at Google. So this is a framework to run machine learning models, deep learning models. TensorFlow, also from Google. Scikit-learn, which is independent library, very good library. PyTorch, which is from Facebook. And there are many others. So we're talking about using private cloud, private data center with GPU-enabled servers. Also, there are certain areas where custom models are still required, and you still need to train a custom model maybe from scratch. The examples may be related to detection of something, like, for example, detection of defects in manufacturing, fraud detection, anomaly detection. In most of these cases, it's possible to use pre-trained models, which makes training cheaper and faster, but still you need to train them. Okay. So the conclusion is that most of data science tasks are based on tabular data and don't require deep learning at all. For some tasks, when deep learning is needed, it can be prototyped very fast on major clouds using pre-trained models and transfer learning. And for cost savings, the deep learning models can be moved to a private cloud. Thank you.